Welcome back, dear friends. The laser cutter and actually everything in the workshop has just stopped working, so time to do some electronicals. Another day and yet another repair job to do, something else to fix. There's the normally has a cover on it, but I've just taken it off. There's the light switches, those 6, and there's the sort of master or main light switch that switches them all on and off. And there's the main power switch that switches all the power to the ring main in here on and off. 20 amp double pole, it's all fused at whatever it's meant to be, so that's absolutely fine. I put this in about, it's got to be 20 years ago, and I've had the contacts on this one, the power one, wear out after about 10 years. I've had to replace it once before because it all starts crackling and arcing suddenly. It's not a slow thing, it just suddenly does. So I've got a new one. I'm going to replace that because I don't want to risk, as has just happened, getting the laser cutter cutting and then finding that starts sparking and then it all stops halfway through. How annoying. Time for repair, and they've just delivered it, so I've got the parts now. Lovely. New switch installed. Let's give it a go. Turn the power back on in the meantime. Oh, lovely. No crackling and arcing. Nice bright neon. Right. I've got to show you this package from Climatic Electronics, because I was thinking, this is a very big box. I don't remember ordering that much stuff. Look. How amusing. It's a piece of error board. That's so funny that they've put it in a box diagonally. And a load of little capacitors stuck to the back of it. Bless. How funny. Right, back to the Climatic Revelator. Now the first thing to do is to put the sprocket on that drives, and the motor that drives the chain, because it's the first place to start. That's where the chain goes, and then I can sort out that and then the chimes. Now in order to do that, I have just cut out, and that's when the power flickered off, this bit, something I forgot the other day, which mounts the motor on the inside of the enclosure there. There's a bit on the outside to hold that big bearing, and then there's the bit on the very outside, there's the bearing. The idea being that that hole gives you room to put the the grub screws in. That was the problem, that's what confused me for so long. Just getting it all together. At one point, I always go on about, is having lots of slacks, lots of movement to adjust it, because however carefully you manage to design this and cut it out, it never quite lines up properly. I just realised, idiot, I didn't drill a hole in the top here to put the Allen key in to tighten the grub screws. What a fool. So, highlighted yet another part of the drawing to remind me, because I was pleased to see it was on there, I just didn't notice it. Get that done. Finally, I've got it done. There's the hole, and that allows you to poke an Allen key in and gain access to one of the threaded holes in the spindle, so you can put a grub screw in both sides, because obviously the shaft of the motor is flat either side. So that's great. Stick the jewel on the end, because it's all a little bit too brassy there. There's a little bit of red on the end, so I'll get that done. Lovely, and then, ooh, move on to the pulleys. I've got the bearings pushed in that, top and bottom. Ooh, that's pretty, isn't it? I was about to stand it up on the stand to fix this on, and realised, of course, that wasn't fixed on, so that could have fallen off, which would have been a pain. So I have just screwed on this centrepiece. You can see how close it is to everything. There's so little room. It took, as I said before, ages to design. So what I'll do now is to get the mirror. There's the mirror with its protective film still on. I've got to countersink the two holes, and as you can see, a strange shape. That took ages to work out as well. I think I managed to draw it out on CAD, but mainly used experiments with card to try and get it to fit inside here and up through that front hole. Hence the strange shape. I was so thrilled when I came up with this idea, because it's got so many lovely features. Because of the lens on the front, that makes it look like this is embedded in the wall. It's sort of an optical illusion, and the fact as it turns, it all seems to go back to front and the wrong way around, which is lovely. Very pleased. Right, I'll get the top. I'll try and get that on. Fingers crossed. Ow, not quite yet. That it all fits on without cracking anything. Say hello, hello. brilliant. That went on a treat. No cracked plastic, everything's nice and flush. The mirror just misses it. It's standing vertically. Oh look. Two lovely spinny things. I've just screwed this M6 dome bolt on and put a bit of the Loctite stuff on it. Just finger tight because I don't want to crunch the two bearings together, so that's good. I haven't fixed the back on, but that's what we're talking about. 3 slots, 3 screws, and we can adjust it by twisting it because it's offset. The great thing is this rebate, again, yet another use, because it gives enough room to have this 3mm bit of acrylic there. So whilst I'm sitting here admiring my handiwork, and that glue is drying on the M6 bolt nut rather, I'm going to build the tensioner, because I've got all the bits painted. Lovely. I've got all the bearings, other bits and pieces. Let's get that together. The centre part of these bearings doesn't actually stick proud of the rest of it, so if you just tighten them down with a nut, it seizes up. So what I've decided to do, I've made some little card spacers from that lovely metallic card I use for so many things, and that just pushes on, as you can see, first, and then the nut tightens down on there, and it works a treat. One top tip, which is why I'm whittering on yet again, if you're cutting out small washers, leave a little tab attaching them, because otherwise you cut them out, and obviously this took me a very long time to realise, but you cut them all out and they fall through the holes in the honeycomb table and you lose them all. Whereas if they're like that, when you want one, you just bend it up and it just snaps off. Anything cool. So I've got that screwed down and adjusted so it perfectly spins. A nice little card jig there allows me to line up the tensioner. So I get that screwed down as well. I was about to start working on the chime mechanism and thought, hold on just 1 minute. With all that rattling about and me then having to sit it flat to get on with the electronics and stuff, it's just going to get damaged and everything. It'd be very annoying. So I thought I'd get on with the electronicals first. There's the lovely little PIR sensor that I talked about before. This is by Panasonic and it's a AMN11111. 3 pins, plus 5 volts, 0 volts and the output, and it just fits beautifully into one of these rivets that I've talked about before that I use on the machines for a variety of reasons, partly because they make really lovely window frames things, and also they can be used to allow a USB type B, I think, style plug to get into an Arduino without having to take everything to pieces when you want to reprogram it. That is a great boon. And they fit inside a standard 15mm plumbing fitting. Now I'm going to have a right angular one here, facing forward like that, and I want the PR sensor facing forward as well. And I found, as I happen to have this size, that size of fabric rivet, and that size is the perfect size for that size to go into. It's brilliant. So I'm going to get that glued on. And whilst that's gluing, I'm going to assemble a little circuit on the back, because I found that the output needs to be pulled down by 68k so the Arduino can read it properly. I'll get that done, and it's so small that it'll actually fit within the plumbing fitting. I'll put a heat shrink sleeve over it. There we are, circuit built, coloured wires put on. Sticking to the right colours on here so I know at the other end of the references they're the right ones. Now I could use, and I have done on other machines, this sort of PIR sensor. They're mass produced, millions and millions of them, so they cost, you know, £2.50 each I should think you could get them for. Whereas these ones are £21, that's the cheapest I can find them for at the moment. But, you know, it's just one of those things, the benefits outweigh the cost. And that will just push into there. The way I like to line these up, dear friends, is with some super glue around the inside of this, and then just a position, super glue around that, position that, turn it upside down, it'll probably all fall to pieces. And then I'll get some araldite. There we are, just dripped epoxy resin around the back. I'm trying to avoid the thread as much as possible. It's quite tight down there. And that's just araldite, whatever, 2-part epoxy resin. I'll leave that to set. That's 5 minutes. It's rapid. Whilst that's setting, rather, I'll get on with the next part. Here's the 3-watt LED support. Over-engineered, you say? Surely not. Well, my rationale was, because this is obviously 10mm thick acrylic, is a 3-watt LED, if it did work at the full 3 watts, enclosed in a small enclosed area such as this, would be a little bit of a nightmare. Very, very hot. So it's mounted very securely, so it can't possibly drop onto anything or face the wrong direction. It's also got, these are lovely, these are keys, warm white 3-watt LEDs. There's a little transistor down there. So you supply it with +5 volts, 0 volts, and then a signal, pulse width modulated output from an Arduino, for example. And that does all the switching, so you can fade it up and down. Now on this design, the Climatic Revelator, it flickers, because that looked nice. I managed to try all sorts of different flickerings. And I found an arrangement in the sketch that just looked perfect. It didn't switch on and off, it just sort of faded a little bit. And therefore that's going to control the pulse width modulated output, is going to stop it from getting too bright. The safety features, 2 of which there are, the supply, the +5 volt supply, runs through 3 diodes, and there's a 0.7, I think it is, volt drop across diodes. So that's going to take off it's going to take off something or other, 2.1 volts or something. So that's good as well. So it can't run at the full power. And there's also a fuse wired in the series. And I can't remember what value that is, but that 250 milliamps. So that'll also add a bit like a resistor. But if something went wrong and that tried to draw full current or too much current, it'll blow the fuse. Hey, thank you so much. So we can now get that fixed in. Oh, I got the switch done, that glued nicely into there, and then it's got the 3 positions sticking out. And the LED, the motor, there's the sensor, so the LED ends up, because it's quite limited space, ends up something like that. With 55mm away from the window for the scenes. But it's okay, because as I say, it runs really, really dimly. 3 watts when I tried it, it was like you couldn't look at it, it was so bright. So it's running very, very dim. And here's the wonderful BMP 180, I think it is, the barometric pressure sensor. It's in that titchy little box there with a hole in it. And the other other components on the board are to take 5 volts down to 3.3 and level shifting, so it can work with 5 volt things. Every time I use one of these, I'm absolutely amazed that you can just read the pressure down to an accuracy of 2 decimal places. It's incredible. If anyone knows how they work, I'd love to know. Please let me know in the comments, because I think it's something to do with like little nano machines. Absolutely incredible things. And there we have it. All the electronicals and the components are all installed, the sensors and the outputs and things. So now I'm going to start soldering all the lovely colour spaghetti together. But first I need to make one of those little bus bar things up out of variable for the +5 volts and 0 volts. Oh, the joy! I do love a bit of soldering. So I've got all the 0 volts to there, all the +5s to there. Now the next thing is to connect everything up to the Arduino. That's it then. Oh, and the meter, that's right. Luckily I've got my instructions there, so I'll just work through them and get everything soldered together onto header pins, so I can just unplug them if necessary. It's 10:15 in the morning and I've got it all wired up. That's amazing. I'm so pleased that I've got a bit more energy today. It's incredible how quickly you can achieve things when you have. Right, the next thing I think is to get the whole lens assembly thing made. Now this is interesting. I've got to cut out this funny shaped piece that sits on the wooden piece that supports the lens and things. And that's out of 3mm acrylic. Now I found this sheet of acrylic that it didn't quite fit on, and then I thought, hang on a minute, because it's the middle bit, the bit that goes round there, and it just fits. So the first time ever I've actually put the sheet of acrylic in at an angle so that the laser can cut it horizontally, because it's just easier that way. Fingers crossed it could all go horribly wrong. So it's got to cut out the little twiddly bit first. Brilliant. Well, I'm so pleased because I hate wasting plastic, and it's just, oh, go away. That's it. If we take this over to here, you can see that that just fits on there beautifully. So I'll get that sprayed up in brass, and that looked lovely, not against the white background. There, that's a little bit better. Against the carpet of invisibility. I'll get that sprayed up then. Hold on a minute. Is there a shadow and sunlight streaming in? Good heavens, I thought it was still meant to be the rainy season. I'd better close the curtains quick. I've now got some felt to cut out. What a joy. It's just so quick, and it cuts out things beautifully and slightly melts the edges. Oh, it's a joy. Oh, I love it. It's a little bit later. I've got that top bit on and all lined up, using the wood to line it up with the circle. Got those holes drilled. Now I'm working on the switch. This is a lovely switch. Oh, and one of the pieces of felt that I've cut. And because it's obviously going around scribing an arc, I thought it needed a curved one. I haven't built one of these on any other machine, so I thought that would just look lovely, and it certainly does. The way I found to do it is just to obviously laser engrave a piece, have a 10mm piece of acrylic cut out, and you just hold it really tightly while the super glue sets, and then it's beautiful. You just have to take care when sanding down the extra bit at the top and bottom, because this engraving plastic melts really easily and gets very hot in the sanding machine. So I've taken it down almost to the right height, and now I'm just going to use some wet and dry with me manual labour so it doesn't get too hot to finish it off. Heavens to Betsy, it's time to get the chiming mechanism together. I've got the bearings on. There's the standard bearings I use, which are 13mm outside diameter, 4 inside and 5mm thick. Most useful. There's the one that's going to be pushing the hammer outwards to prime it. Potential energy, that's right. And here's a little thing that's going to be lifting up to release that, to turn the potential into kinetic. I only thought I'd mention it because my son and daughter are currently doing GCSE science, so I'm becoming familiar with those phrases that I haven't heard for about 40 years. I've reached one of those juxtapositions, well it isn't actually, but it sounded nice, catch-22 positions, I don't know. Whether to fix that on, I need to know how high it is, and I've just realised, because I was about to do that, that I can work out the centre of that. That's 58 from the outside, but that depends on the height from that pulley to this pulley once that's fixed to that, so I can't do that yet. And the thing that holds the bearing up here that returns the chain, I can't do that until I've got this done. So I can't do that until I've got that done. So I think the next thing, funnily enough, is to make the chimes, because I want to get them strung up to there before I actually start mounting everything together. And the measurements are here. So I've ordered some more of the nice thin aluminium tube, so I'll get cutting and stringing. And the trick is, I know I've said this lots of times, but I couldn't get them to make a sound. And then I realised that if you drilled a hole 30mm down from the top, they would chime, because the elastic nearer the top was absorbing all of the sound waves as they bounced backwards and forwards. So it was just nothing, it was just a thud or a clunk. Now someone at the time, a few years back, did message me and say there was an equation which I have written down somewhere, very safe, that obviously I can't find, but there's some sort of percentage or something that you can calculate how far down to have this optimal hole. But having done lots of experiments for these anyway, 35mm was perfect. Cutting pipes is such a joy. I wonder how many plumbers ended up becoming plumbers after they discovered how much of a joy it actually is with one of these pipe cutters. Oops, I just love it. I still can't get over how lovely it is, because you imagine the alternative would be using some hacksaw or something and then having to file it all, especially with this really soft aluminium. I'm only tightening it a titchy little bit each time. That, an absolute perfect cut. I can whiz around the inside of that with my deburrer. That's lovely. Another handy jig that only became apparent after I built 2 or 3 of them, sort of struggling with all this lying flat, and then thought, hang on a minute, hang it up. And the elastic just comes along, down, up, down, all the way round, and oops. Isn't that lovely? And I've just realised, of course, each time I do one of these, I've got to glue the ends of the elastic in, and there's only the same size slot that normally just it comes up and goes back down. So for the first time ever, I went back to the CAD drawing and added 2 little slots. So I've got the start and the end of the elastic. How fantastic! It was all going so well. Let's get this hung on here. Then I put the screw in through the 2 bearings, and it's on a wonk. It's an angle. It's not vertical at all. That'll never do. It's like a millimetre out on this side. I don't know how I've managed that. Here's my de-wonking device. Crazy, isn't it? But I want to get this done properly. So I've got it all lined up vertically and everything else. And I'm going to really slowly drill that to 4mm. Then put the thread in and then hold the thread in the chuck and glue it in and take the dog for a walk. So there's the M4 stud. Holding it perpendicularly in there, drip some super glue in so it should really fix solidly, and I'll come back and try and get it all assembled once we've taken the dog for a cycle. Well, I ride the bike and she runs. It's working beautifully. You can see how it works. If I turn this, that pushes it out and the pull drops down, and then the pull's lifted. And that's why it works both way around. So this drawing says it's 58mm in from the outside, so I've marked that with some masking tape, which I've previously stuck on my top, my fleece, so it takes away the stick so much, little top tip there. Otherwise, if I stick it on, peel it off, it'll probably take some of the stain off. So that's centred that way, and I've got this rod, which is parallel to the top of the machine. So I've now lined up where the chain's coming off that pulley so it can come around this one, and I've marked the 2 holes. So that's screwed down nicely. Now I'm going to screw this down, marked it out, and the classic old top tip that's quite a favourite with people, understand, is if you're going to use wood screws, put wood screws through a hole into a piece of wood, it'll turf it up if they're big wood screws, and you'll get a little mound of wood that'll push whatever it is up, stop it sitting flat. If you countersink the hole slightly, it stops the problem. I've just had a very good idea. In the past, when trying to work out where to line this return pulley up, I've spent ages putting one rod up there, 1 3mm rod along there, work out. I've just realised, of course, if I bend 90-degree bend in it, and get that one lined up with those bits, and this one lined up with that bit, Bob's your uncle. Got another spinny thing. How lovely. That's the final spinny thing. So the next job, now the mechanism's all done, is to get the ball chain. So I need to make an endless loop of ball chain. I've just looked through the whole lot of the notes twice. Finally found it on the back of the first sheet. Cut chain to 634mm, then join ends. I know I've mentioned this lots of times before, but just briefly, I use one of these tools with a little spike to open the ball that I want to join onto, and then with the aid of some blue tack, I found is the easiest thing. Just get a little eyepiece out of the end of one ball, and I've split open another ball again with that little spiky thing, and I found the best way is to use a pair of pliers just to close this ball up around the eye. And there we have it. It's a joy putting this chain on because you can link it up and you don't need to unlink it to get it all round everything. And you can see there's the tensioner. I've added the spring now, and that just bears down on there, so it just creates a kink in the chain which keeps it all nice and tense. Now I can't try it yet because if you turn these motors, they're so highly geared down you can damage them if you twist them too much. So now the next thing, I think I'm going to put the title on it and then put the lens on it, then connect it up. Yeah. Title mounted on its two little brass tube legs. Now onto this bit. So that sits on there, that's 3mm thick. There's some 2mm spacing bits that go around there, and there's the front on. There's the lens. Isn't that amazing? Because it really looks like there's a dome of glass there. But it's a Fresnel lens. Which these lenses are meant for book reading. They come like that, obviously. And you slide them along. Let's have a look and see if it works. Yeah, that works, doesn't it? Lovely. But they're not that good a quality. They're perfect for this sort of thing though, because they do provide a nice bit of distortion. Lovely. Thanks very much for watching. Hope you found it enjoyable. Next time, actually get the whole Climatic Revelator together and hopefully working. Fingers crossed, which I can cross now, they're finally healed. Please click like, subscribe and the other stuff. Hope to see you next time. Oh, and remember, I always forget to say this, all my stuff that you see is for sale on my Etsy shop that can be reached by visiting my website, steamhead.co.uk. That's right.